The aim of this short video is to introduce you to colour management. We all see colours slightly differently. Colours also appear to change under different lighting conditions and when different colours and tones appear next to each other. Colour is also produced differently by different hardware devices. Monitors display colour using red, green and blue pixels, while printed colours use cyan, magenta, yellow and black ink dots. In the ideal world, we would work under very controlled conditions to avoid our eyes being misled. So let us have a look at some of the factors that affect the way we interpret colour. Hue induction. Our eyes recognise objects under all types of lighting. The brain perceives relative rather than absolute colour. In the example we have here, the abundance of blue colour confuses our eyes and the child's shirt appears to have a warm tone. When we zoom in, we can see that it is actually grey. Another factor to consider is known as the Bezold effect. The presence of very dark or very light areas in a scene can alter the way we interpret neighbouring colours. A dark background increases contrast and the colour appears more saturated. With a light background, the colour appears lighter and less saturated. To minimise the possibility of confusing colour in our images, we should ensure that the environment we work in is free of brightly coloured objects. Walls should be painted a neutral colour, lighting should be subdued, and if possible, windows should have blinds. The computer desktop should also be a neutral tone. Most digital images exist on a number of different devices during the image journey, from capture through to final delivery. At each stage, the colour may be influenced by the unique behaviour of each device. With careful measurement and adjustment of each of the devices used in our system, it should be possible to manage the colour of the image and make colour more consistent throughout its journey. This process is known as colour management, and it involves measuring the accuracy of each device in the system and recording its behaviour. This is referred to as calibration. Early digital image workflows, often operated by commercial printers, used a closed-loop colour system. This normally worked perfectly, providing that all capture and output was undertaken internally. If we look at a simple closed-loop system, we would have an input device or scanner, a computer and an output device, normally a printer. Each device should be calibrated for accuracy. If there is a colour problem with the print, corrections can be made at the printing or capture stages. Today, images are widely circulated and come from a huge range of sources with unknown final uses. A closed-loop system would not be practical for most modern digital imaging environments, so we have to find another way to control colour. A group of interested organisations joined forces to create the International Colour Consortium, or ICC. They recognised that the community needed a system that would provide consistent colour in a more open environment. Together they devised a process that could measure the devices used in the system and compare them to a standard colour space. The unique behaviour of each device is recorded in the form of a profile which can be embedded in an image. The open loop system, which is widely used today, requires calibration of each device in the system. This creates profiles which are used to give meaning to the colours in an image. With careful and consistent calibration, the open loop system can deliver the same high quality seen in a good closed loop system. The standard colour space used in ICC colour management was developed by the Commission Internationale de Éclairage, or the CIE, in 1931. The CIE colour space describes the total range of human colour vision, and we use this to compare the characteristics of all devices. The colour limits, or gamuts, of all devices can then be compared to this CIE colour space. The process of recording the behaviour of a device and creating a profile is referred to as calibration. In each case, the colours captured, displayed or printed are compared to known colour data. Monitor calibration requires special software and a hardware calibration device that can be attached to the screen. The software displays known colours and the calibrator compares this to the original perfect data. The results are recorded in the profile, which is then stored in the computer's system. Scanners and cameras can be calibrated using accurately printed physical colour targets. These are captured before special software is used to compare the original colour data to that which has been recorded by the scanner or camera, and then a profile is created. The profile can then be embedded in the image. Printers are normally supplied with generic profiles. Due to variations in the manufacturing of inks, paper and printers, the accuracy of these profiles can range from average to poor. Custom profiles provide greater accuracy and reduce ink and paper wastage. To calibrate a printer, known colours are printed. The colour of the print is then measured and a profile is created. A new profile should be created for each paper and ink combination. Image editing applications can be customised to suit different types of work. This is the control panel for Adobe Photoshop's colour settings. The top option offers preset for different types of work, such as commercial printing, online use, etc. The working space option allows the user to select the most appropriate space for their work. Commonly used spaces include Adobe RGB for standard print use, ProPhoto for very large colour gamut work, sRGB for normal screen and web use. There are also options for selecting CMYK spaces for known printers. The colour management policy options allow the user to decide how images using profiles that are different to the Photoshop working space are handled. Normally this should be set to preserve embedded or convert to working space. It is also good practice to switch the mismatch warnings on. So which colour space to use? Most new cameras are set to sRGB by default. However, they will normally also offer Adobe RGB and possibly others. sRGB was developed for non-colour management systems. sRGB images will normally look good on all screens. However, the gamut is considerably smaller than other colour spaces, and this space is not suited to work destined for print. Adobe RGB has a much larger colour gamut than sRGB and is more suited to images destined for print. On non-colour managed systems, however, Adobe RGB images may look duller than sRGB equivalents. Other colour spaces include ProPhoto RGB, which is a very large colour space and stores considerably more colours than can be viewed on screen or printed. This space is used for very high-end work. Images only ever destined for screen use should be saved as sRGB. Images that may also be printed should be captured in the larger gamut Adobe RGB and converted down to sRGB when desired. So to sum up, colour varies between devices and can drift over time. Calibration identifies device traits and attaches this information as a colour ICC profile to an image. If you can only afford to calibrate a single device, calibrate the monitor.